Hi and welcome to this walkthrough of a thiosulfate iodide redox titration question. Again, I'm using the data moles, equation moles answer technique to help illustrate how you can use data from the question and park it in different places in your calculation to make it nice and easy to process. This is a slightly more unusual example because it's got dicyanide ions, something that you don't come across very much in A-level syllabuses, but it's no reason to not try it. So as always, the first thing to do is to identify the things you might need later on and possibly highlight them. So the thing about thiosulfate titrations is they are a little trickier than manganate titrations because there's two stages to the equation. So if I put my highlighter on, you can see there's this initial stage and then the thiosulfate comes in the second stage. So you've kind of got to work your way backwards through the equation to work out the relationship between the two things highlighted. So taking the data first of all, it gives me the fact that there's 50 centimeters cubed, so that's my thiosulfate volume. My concentration of thiosulfate is 0.800, so I can easily do the moles of thiosulfate as V times C, which gives me 0.04. Now in the equation, the number of moles of thiosulfate, the number of moles of dicyanide is 2 to 1. So what that means is for every 2 moles of thiosulfate, it reacts with 1 mole of iodine. The iodine comes from the reaction of dicyanide with iodide. So coming out the other way around, 1 mole of C2N4 reacts with 2 moles of iodide ions to make 1 mole of iodine molecules, which then go on to react with 2 moles of 2S2O3. So combining those two equations, you can see there's a 2 to 1 mole ratio. So that allows us to work out the number of moles of dicyanate. So you have the number of moles of thiosulfate. And not forgetting, of course, there's a scaling factor. So it was 250 centimeters cubed it came from. So 250 divided by 25 gives you 10, with which you multiply up 0.02 to give you 0.2. So adding up the molar mass of C2N4 gives you 80 grams per mole. So 0.2 times 80 gives you 16. So a quick check of the mark scheme and just pitching it against data moles, equation moles answer, you can see where each of the marks are actually gained. So the data moles, equation moles answer allows you to work your way systematically through the marking points. Okay, thanks for listening. Until next time, see you soon.